Hello everyone, welcome to my channel. In this video we are going to see about the differential protection. Normally the differential protection operates when the phasor difference between the two electrical quantities which exceeds a predefined value, which means the name itself you can easily came to know that the difference between the two quantities, it may be a current or voltage or power. So in order to compare the two quantities, we are getting some of the values which will overcomes the predefined value. So in this case the differential, the main phenomenon works. Then for example, current differential relay operates on a comparison between the phase angle and the magnitude of current entering and current leaving the system to the protected zone. So as you know, the differential protection is the main thing which are commonly taken place in the protection, which means it may be a differential busbar differential or transformer differential or a line differential, which means a line entering and outgoing in the busbar, which means like a bay differential, and also one input one incomer with a numerous number of outgoing. So in this way the connections, the differential naming is T differential. Then if the differential is taken place in a cable, means it's a cable differential. Likewise the differential conceptual wise same, but the locations differs. So in order with the priority of location, the namings also differ. In this video we are going to see the current differential relay, then biased beam relay or percentage differential relay, then voltage balance differential relay. So first thing, the current differential relay. The current differential relay is basically the differential between the two CTs. In this case both the CT are having same ratio, which means if the CT is a 200 amps or a 2000 amps or even a 4000 amps by secondary 1 amps or 5 amps. So in this case both the end, which means the CT1 and CT2 both should be in the same ratio, and also the secondary current also should be in the same level, which means 1 amps means 1 amps in both end, and also 5 amps means 5 amps for both end. If you want to know more details about the CT means, you can refer my any other videos. In that the CT ratios, then knee point level, then what is the CT mentioned as per if it is a metering means why it is mentioned as a metering, then protection core means why the protection class should be taken for a protection, then 5P15 5P20, this kind of differences are explained in another video. So right now coming to this point, so in this case we have a two CT and the zone to be protected is it comes inside the CT of these two CTs. Then here the current entry, it goes down and it will turn back, forms a circular path. This current is a I1, then same wise it's going there, then current entering, then it goes like where and returns back. So this is a CT2 and the current is I2. So in between both the current, one operating coil will be placed. That operating coil which carries a relay sections, and that relay is a differential relay. Then normally the main conceptual wise, the main thing is that the differential relay should act only for the internal fault, which means the zone to be protected, that in that zone of fault only to be carried, and the fault should be given as a alarm or trip. For the external faults, it should not act, or else for external faults for the external fault it may be taken as a overcurrent or a earth fault, whatever it may be, that will goes the external side. So in that time the differential relay should not act. So as the CT is identical as same ratio, the secondaries of the CTs will carry a equal current. When an external fault, no current flows in the relay operating coil. This is the main thing. When an external fault, the fault is in the outside the zone, so the operating coil should not get any induced current or anything. Hence the relay will remains inoperative, and the differential will not act for the external fault. Next thing is that if the fault is internally inside the zones, means in that time the relays should operate. So as I mentioned, the fault is inside the zone to be protected. In this case, the current flowing will automatically alters, which means the current entering and the fault side, the current will goes in a reversal level. So in this condition, both the I1 and I2 get added, and the operating coil will exceeds the predefined value of alarm or trip. So in this way, the differential relay is acting and gives the alarm and tripping signal to the breaker, and the breaker get trips. So this is the basics of the current differential relay, but this is having more number of disadvantage than the advantage, because here the CT ratios, as I mentioned, should be in a same ratio. If it is in a different ratio, means then there should have a should overcome these feedbacks. And also the pilot cable which we are using, this is the secondary cable which we are using, so this may carry some of the additional capacitive elements, and also it may cause an unofficial fault or a unnecessary trip, or even a fault tripping may cause many damage to the protected zones. So to overcome this, next thing we are going to see is that biased beam relay or a percentage differential relay. In this relay we have a two coil, one is the restraining coil and the operating coil. Earlier one we have only one coil, which is the operating coil, and also the zone to be protected is carried out, and the CT secondaries, one terminal is connected with the restraining coil and another one is connected with the operating coil, and the tripping circuit is connected with this beam. So whenever the this beam enables, and it will make the tripping contact, and the trip will be initiated to the circuit breaker. Next thing is that this is the circuitry diagram of the biased beam relay or percentage differential relay. Here main thing is that the operating coil is placed parallel to the both the I1 and I2 current, but the restraining coil is in series with I1 and I2 current. So in this case, both the I1 plus I2 divided by 2, which means the average of the both the current, it is your restraining coil current level. Then the operating coil current is that I2 minus I1, which means outgoing minus the incoming. Here the main thing is that the incoming and the outgoing should be in the same level, or else within a minimum level of our alarm or tripping. So there will be no false tripping, or even any transient trippings also not to be done. In order to that, we are mainly focusing on this. Then the main thing is that here the CT ratio should not can be in the same ratio level, or it may be in a different ratio level also. To overcome this errors, the main advantage is that in here the restraining coil is used for using the different type of CT ratios, which means it may be a 2000 per 1 amps, it may be a 4000 per 1 amps. The restraining coils will take care of this, because the main thing is that under a normal condition and through a load condition, the biased force which created by the restraining coil is greater than the operating coil produced by the operating coil. So in this time of condition, the relay will not be in a operating, which means the relay will not operate. So the circuit will be healthy in a healthy condition, which means in a external trips or anything happened, in that time the circuit will be in a healthy condition only. There will be no more any transient or fault tripping will be happened. So during the internal fault, which means the fault occurring within the zone, the operating force becomes more than the biased force. Due to this, the beam moves and the tripping contacts are closed to the circuit breaker to be open. So that this is the main thing. Here at the starting, the current will be fluctuating. After going on, the current will be in a same manner. So the ratio of the differential operating current to the average restraining current is in a fixed percentage. That's why we are calling this as a fixed differential, which means a percentage differential relay. Next thing is that voltage balance differential relay. In here, a relay coil will be connected in series with the C1 and C2, which means the CT1 and the CT2 of the current transformer. In here, the overcurrent relay is connected in series with the secondary of the CTs. So under a normal condition, the current at the two ends will be same. Hence, there will be no voltage drop in the relay, and the relay will not cause any of the overcurrent or a fault current to enter into the relay and get any alarm or differentiation. So under a normal condition, there will be no voltage drop and the relays will be in a inoperative manner. And when there is any fault, means under a fault condition, the current in the two CTs are different. This causes a large amount of voltage drop in our relay. Thus the voltage balance of this circuit will be get disturbed and the large current will flow to the relay, and which cause the tripping circuit to get tripped or else initiate the trip to the circuit breaker, and circuit breaker will be opened due to this internal fault. So the main motive is that the differential relays are used for an internal protection, which means the within a zone of protection these differential relays are used. That's all for today. Keep watching my video, share your knowledge and gain your knowledge. Thanks everyone. Nandri, Vanakkam.